Well, good morning, everybody. Welcome back. This is Mike McGee again coming at you. Wanted to welcome back our guest contributor today, Mr. Matt Manning with VVAX Metrotech. This is session 2 of the EGW Utility Solutions Conference. We know how valuable your time is, and we appreciate that you've chosen to spend yours with us this morning. The title of this session is Advancements in Utility Pipe Locating Through GPS Mapping. Again, Matt Manning with VVAX is with us, and thank you, Matt, for taking some of your time to share with us. We really do appreciate it. Before I get way down the road, I want to mention that these sessions are being recorded and that we'll be making these videos available in the next few days via our YouTube channel, so keep an eye out for that. We'll be making an announcement. As you're probably already aware, we are giving away a door prize in this session. The door prizes have been sponsored, and we want to thank all of our sponsors for their contributions that benefit these sessions and also for their overall support of this week's event. We really appreciate it. This session's door prize is being sponsored by VVAX Metrotech, and I believe it is a $100 Lowe's gift card. So good luck to whoever wins that. The drawing will be held directly following the session, and you will be contacted if your name is drawn. Here in just a minute, I'll introduce Matt, but I want to first remind everybody about some ground rules for the sessions. You can see that we're bringing this conference to you live via Microsoft Events. This format is a lot like watching a live stream on social media. So while you're viewing us, we know you're here, but we can't actually see you and we cannot hear you. So there's no need to mute your microphones. You can, however, interact with us, and we encourage you to do so. You'll do that via the Q&A chat function. You'll notice that little chat bubble at the top of your screen. That's the one that has the little question mark in the middle of it. And if you click that, it'll open a Q&A chat box, and you'll be able to submit questions. As the questions come in throughout the session, we would encourage you, as they occur to you, I should say, we encourage you to submit those via that function. So just type that in and you'll send it, and I'll collect the questions as they're submitted, and then I will be relaying them on to Matt when we transition to the Q&A portion at the end. So just kind of a side note, you won't be interrupting us at all or interrupting Matt if you submit your questions as they're in progress or as he's talking. So I'll be in charge of just collecting those and giving them to Matt whenever we get to that point. Okay, that's it for the ground rules. Let's go ahead and introduce Matt. Matt Manning started in the utility underground industry in 1989 for an underground utility equipment dealership as a parts manager. It was at that job that he was introduced to utility location equipment. In 1993, he went to work for a manufacturing company that focused on trenchless boring equipment, utility location, and directional location equipment. He started as an outside salesman, and in 1994 moved to an outside sales position. In September 2016, he went to work for VVAX Metrotech as their Southeast Regional Sales Manager. So now, without further ado, I will hand the controls off to Matt, and he can take it from here. Matt, it is all yours.
Thank you, Mike. Once again, appreciate y'all's time today. Appreciate the questions that you would have at the end of the slides. So what I'm going to be talking about today is the VLOC 3 RTK Pro receiver. This is our unit that we introduced in April of last year. And it is a unit that will allow you to utility locate and precision map your utilities to survey grade accuracy. So what the industry has been doing for years as far as mapping, they've been using normal GPS receivers, scanners, subsurface locators, drones for all mapping underground utilities. It's been going on quite a while. Basically what they want to do is they want to map their assets for mapping out where their gas valves are, their gas meters, their underground lines. The problem that the industry has always had is that the GIS department that generally does the mapping and the utility locators that do the mapping, that do the locating, are not in contact with each other or not on the same page lots of times. GIS, people know a lot about GIS mapping. Utility locators know a lot about utility locating. But to get those two groups together has been a little bit of a challenge. Generally, the way it works is a crew will come out, locating crew will come out, they'll map the utilities, put the paint on the ground. Within a day or two later, the GIS group will come out and map those lines. There's a lack of communication there. One of the things everybody's wanted to do was be able to attach that underground utility information from the locator directly to a GPS device. In the past, we've done this either by Bluetooth connection or cable connection to a GPS device, to where the locating technician had a utility locator in their hand and then some type of a survey equipment either in their hand, on a backpack, or on a pole. Well, what we've done is we have included a GPS antenna and a SIM card in the receiver, which gives you utility locating capabilities, mapping capabilities, all into one system. This allows the utility technician to operate as normal while they're using the utility locator and painting the ground. So what we've done to achieve this, once again, as you see in this picture here, on the top of it is a GPS antenna. We've added a nano SIM tray for cellular connection. The cellular connection is doing two things for us. It is connected to the internet, and through the internet connection, we are getting a RTK correction, which I'll explain in just a minute. And we're also sending our data to the cloud. These are the dimensions of our utility locator. You can see it's a standard system, standard size as the average utility locator in the market and our previous equipment. So what is RTK? Basically what RTK is, the simplest way to explain it, is there are base stations that providers place throughout the state, throughout the US. They are survey grade mapped in. That device knows it's lat and long. So as it sees the satellites and the satellites tell it where it's at, it knows that there's inaccuracies within that lat and long information. Because it knows where it's at, it knows where the satellite is telling it's at, it can make those adjustments, sends it via the internet, our receiver, because the SIM card is connecting to the internet, getting those corrections. It's also seeing the satellite, so it knows the corrections that need to be applied to get us the accuracy that we get for our survey grade mapping. Just an overview on the RTK. One of the key things I want to mention here, though, is that there are several service providers for RTK corrections. We're using a company called TopNet Live. We have 3 sales guys that cover the US, a gentleman in Canada, and we need a national service. So this gives us, within the our footprint, ability to get RTK corrections. There are other providers. A lot of your state DOTs will provide the service. If your state DOT does not do that, there are other companies out there that provide the services also. Some of them are free if it's a DOT, some are paid for. So on our screen, looks like a typical utility locator screen. But if you notice in the top right-hand corner, we are giving you a cell phone status bar or a cellular status bar. We're also giving you a GPS icon. That's the teardrop icon you see that is green in the picture. So you will know by looking at the screen the quality of your cell phone signal. You'll also know the status of your GPS data. You'll notice on the middle of the screen we have several different icons, different colors, but the red, yellow, and green is what's important. The red means that the unit has a lat and long. It knows where it's at, but it's uncorrected data. When it turns yellow, that is mean we are connected to the RTK service and we're starting to get corrections. It's what you call an RTK float. You can also have an RTK float if there's some interferences from reference an ability to see the sky clearly. Maybe you're next to a tall building or in a heavy tree cover of that scenario. The green icon means that we are getting our RTK correction. It's a fix. That's the most accurate locate you're going to get from a GPS standpoint. This icon is always, on when you're locating, so you can see if it goes from the green, yellow to the red. So the one thing we wanted to accomplish with this, I mentioned the disconnect between the GIS department and the locating department. GIS people know a lot about GIS mapping. Locating technicians know a lot about locating. But we wanted to make this as simple as possible for the locate technician to go gather accurate GIS data. So this is your typical locating screen. It's very similar to most of them on the market. This is our peak screen with null arrows. So you have a combination of two different types of locates in one. But this is kind of standard method of locating. The advantage here is if you know how to locate, you've already been using an instrument. Converting over to our instrument is a very easy process. It's not like we're using a totally different method of locating a utility to do this GIS mapping. So easy for the day-to-day locator to use this. The one thing that you will notice is we have a colored screen. What this color screen does for us, it gives us an ability to give the technician an immediate knowledge of the quality of locate they're getting. If you're going to be mapping to survey grade accuracy, you want to make sure that you're getting the best locate possible. So our locator has 3D antennas in it. Those 3D antennas let the locator continuously look at the signal and give a qualification of the accuracy of the signal. So a green bar graph is going to let you know that there's very low distortion in that signal. It's a very good locate, minimum distortion. When it turns blue, now you have medium distortion. At this moment, that's when the technician needs to be paying attention to whether peak and null match. If you've got a red bar graph, that's letting you know there's high uncertainty or high distortion. And once again, the technician should be checking their peak and null and making sure things line up in reference to mapping. We maintain this color code through our locating screens on the instrument and also some of our unique locating screens. In reference to unique locating screens, this is our vector mode. Once again, you can see the color code in the screen. This is the screen that gives you the ability to locate from the side. Where a lot of technicians would use this is if the cable they're tracing maybe runs just inside the edge of the road. Maybe it's in a low area that's got standing water. Maybe it's in a backyard scenario where your cable is running in and out of privacy fences. But this will give the technician the ability to look at the utility from the side, gain an approximate depth and distance they are from it. Color code comes in here because if you got a green dot, you know the signal's very good, very low distortion. When you see it go to a blue circle, starting to get interference, red circle is high interference, and the information is uncertain. So the next thing we needed to do is we needed to make it easy for someone to store a point. We also want to make sure that where you were locating was also pinpointed with the GPS point. If you look at the picture on the left-hand side, you'll see that the GPS antenna is in front of the locator. The tip of the locator is kind of in the center axis there. So record a point, you find your locate, peak point. You get ready to map it, you'll press the I button, and then you'll see the screen, first screen on the left-hand side. At that point, the technician would decide whether they do or do not want to map it. If they want to map it, they'll hit the plus sign, which is directly beneath the check mark, as you see. All right, but the problem still is the antenna's out front. The locate technician should also, when they find the peak, rotate the locator to make sure it's in line with the utility, but not everybody does that. So what we've done is we've added a bubble level. The bubble level automatically pops up. And what that does, if you look at the locator on the right-hand side, you'll see where now the GPS antenna is directly over the tip of the locator. So this allows you to make sure that the point you just located is the point you just GPS mapped. This also comes in handy in reference to another customer request that we had after coming out with the locator in April of 2020. And that was they wanted to map more than just underground lines. They want to be able to map valves, gas meters, surface items. So this lets you map those items and also make sure the GPS antenna is directly over the point that you're mapping. Along with that request for wanting to map surface items, in the beginning we could only name the utility a gas line or a water line or a sewer line. Customers want to be able to put a little more detailed name with that. So one thing about VVAX that's really great is that we have free software upgrades. These are done through an app that you would download onto your device, laptop, desktop. Make sure you're on the internet, connect your locator via a cable that we supplied, which is still a standard USB to micro USB cable. It will check to see that the software on your receiver is the same as the software on our server. If it's not, it gives you an update. So in the beginning, we did not have this availability, but through software upgrades, we now give the customer ability to add a feature library into their receiver, which lets them add a detailed name. As you can see right here, I can not only name it a gas line, but I can name it a gas main that is 12-inch steel. For our surface items, I can name it a fiber handhole, 3060 by 30, or I can name it a high pressure gas valve, low pressure gas valve, or I can name it a meter. So let's talk about sending information to the cloud. In the past, a lot of this locate data was stored on the receiver and GPS data was stored on the receiver. That meant that at the end of the day or the next morning, somebody had to remove that data from the device. What the SIM card is doing for us, along with the RTA connections and corrections, is letting us send our data to the cloud. So as the technician is out there mapping, the data is constantly being pushed to the cloud. So someone back at the office can open up the cloud, look and see that the technician is finished with a job or still in the process of a job as it's taking place. As far as the cloud, some of the management information is, once again, the data is being sent directly to VM Map Web during the using a secure data transfer. You can view your maps and data in VM Map. Our cloud is a API, open API set up, so it lets customers pick and choose the information they want to remove from our cloud and go into their database. We also set this up in a tiered function. So if a company had a person back at the office, they'd consider the company admin. Then let's say you had a supervisor that was covering 5 to 10 technicians, and those technicians in the field, the technicians can be set up where they can see their data. The supervisor of those technicians could be set up where they can see all of their technicians' data. And of course, the company admin, if there were multiple teams, multiple supervisors with multiple technicians out there, the company admin can see everybody's work. So while the technicians in the field, they could access the cloud to their device and see what they just mapped. More data equals better maps. So I mentioned earlier about locate technicians out there locating utilities. We want to make sure the GPS antenna is directly over the spot where you're trying to map. We also want to make sure the technicians are using the equipment properly. So a couple of the key things that we would record in reference to the locator that's going to let someone at the back office know the operator is using it properly is the percent of bar graph. Where was the bar graph at when the technician mapped it? Where was the dB at? The gain level. We also record frequency and the mode the technician was using the instrument, whether they use it in the peak mode, peak combo mode, or the null mode. This is a sample of data that is exported out to a CSV file via the cloud. You can see right here, if you go through the different points, you'll see the technician here was using peak with arrows to locate. The gain was at 59. Bar graph at 54. We're even giving you the battery life of the receiver. You've also got your lat long and date and time. We're also including the incremental distance, which is the distance between each point. So if the GIS departments want something recorded every 50 feet, you would know the incremental distance was every 50 feet. We also display that on the locator so the technician, as they're mapping, can see how far they are from their last point. We also give you accumulated distance. This has helped a lot of people that are doing as-builts. It's actually giving them the total distance of cable or gas pipe that they installed. GPS data that is being collected. You can see in this one we have GPS date and time, of course, but we're also letting you know what the fix was. Was it an RTK lock, which is where you see RTK there? Was it a float? Did for some reason we lose our satellite view? You have an idea, or you do know that we had some instances here where we went to RTK float. That affects your accuracy. If you totally lose your RTK, it will show that it was just a digital GPS locate. But we can see right here on the far right hand side at the bottom, that's our accuracy. The 2DM, the 2D RMS is our accuracy. We can see right here that we were at 1.11 inches with an RTK lock. When we went to the float, we went to 1.22. So this is an image of what the cloud looks like when you log in. You can see the surveys right here. They are automatically named by date and time. You've got the locator serial number in there, and you will assign the locator to a particular user. You can see the user's name. In the cloud, you can run all types of surveys. You can run surveys by team, by user, what type of utility they were locating, what frequency was the most used. If you had 5, people out there locating, there all 5 would be in the pie chart here, and you would know what percentage of work they were doing. This is what, if you clicked on a survey, there are 2 images you could see. You could see a map image and a satellite image. This is an example of a satellite image. You can see each one of the teardrops are points were recorded and was connected with a line. Once again, more data that you can pull from the portal on the cloud to evaluate how your crews are mapping. The reason I like showing this picture is in the field, technicians see a map. And sometimes, you see the utility on a map, but you're sitting there looking around and the map just doesn't make sense with the streets that you're seeing. If you notice right here, you can see the streets. As I click on the next picture, you will notice they're not technically streets, it's a parking lot. So what the technician was seeing looked like roads on a map was actually where the cars would drive and not park in reference to where the utility is. This gives the technicians in the field just a little more idea of what they're going to be locating in reference to a previous locate. If you were to put the mouse over one of these points, you would pull up the data that is attached to that. You can see right here they were using 8.19 as a frequency, depth was 64 inches, you got lat and long, and the milliamps were 7. You also have your date and time right there. Exporting from the file is a very common question. How many ways can I export from a file? Because I want to put this somewhere. This is going to go somewhere in my database. So we can export as a KML. This is a Google Earth file. The nice thing about a KML is it gives anybody the access to view your map via a satellite view. Reason that's nice is a lot of people out in the field, they don't have access to the GIS database where your stuff may be stored, and this can be shared very easily that way. A CSV file, we also exported a CSV file. Why this is important is there are many mapping databases out there where this information is stored. A CSV file is a very common way of pulling data out of our cloud and importing it into someone else's GIS database. I mentioned before, we have an open API for our cloud. What we're doing here is we're giving the end user the ability to pull that data out the way they want to pull it out, the information they want to pull out, and put it wherever they want to put it. When we came out with this in April of last year, we had a couple of companies reach out to us that are already field app designers. A company called Fulcrum got in touch with us. So we had a common customer that wanted to use our system in reference to their cloud, their map app. And in this particular one, you can see this is actually a cloud to cloud deal. So it goes from our locator to the cloud, to the Fulcrum cloud, back down to the device. In this particular deal, you can see where they have existing utilities, which are in blue. The red dots are where the utility locator mapped currently. We also have a couple of app manufacturers out there that are in the process of working with us also to link our stuff together. This is a shape file. This is very important. ESRI or ESRI, ArcMaps online is terminology that you hear. They're probably the most popular GIS map data storage platform within the US. So we do export as a shape file, and that's what this is a picture of. Also coming soon in our cloud is going to be a way to basically sign in through our cloud into your ESRI account. At that moment in time, you would pick the layer that you would want our data to go into, and it will move it over automatically. So another request we had from customers were they wanted to walk back to previous mapped points. An example where this came from is a particular customer who had gone out to a gas line that was technically unlocatable. There was no tracer wire with it. They used a Jameson system, insertion system, to insert into the gas pipe and map it out, locate it out. While they were there, they also put down some near surface markers. They mapped the Jameson rod with our unit. They also mapped near surface markers with our unit. A couple of months later, because they were mapping this for an 811 ticket, excavation equipment came in to do some landscaping, and the near surface markers, some of those were removed in that process. This company called and wanted to know, is there any way we could walk back to those points? We had already had the request, was already working on it, but that's one of the issues that customers are facing and why they want to walk back. So the way the walk back works is you pick the point in our cloud that you want to walk back to. You would send it to the specific technician that needs it. They would go to their locator receiver. They'd go in the walk back file, pull up the point they want to walk back to, and hit the enter button. When that takes place, you will see the screen on the right-hand side, your left-hand side. And at the bottom, it tells you how far you're away from it. You can see in this one, we're 15 feet away. At that point, you start walking, an arrow will populate. You just follow the arrow. It's taking you to the GPS point. When you get within 10 feet, you'll see the middle screen. The X on this screen is the point we're walking back to, and you'll see the bubble level popped up. So the goal is you'll put the bubble level in the center of the bubble level, and you will put the X in the center of the bubble. That puts you directly over the walk back point. At this time, the technician will make a choice whether to hit the X mark, which is will X you out of this particular walk back, or you can hit the check mark. When you hit the check mark, it lets you know the walk back is completed. It takes it out of your receiver menu and also lets it sends a message to the cloud that will let you know that it was walked back to, and also people back at the office can see that. Once again, this was through a software upgrade. So technicians that had bought units in the beginning were able to get online, upgrade their unit, and get this into their systems. So current applications, some of these are going to make sense, some of them may not, but let me explain them. Mapping existing utilities. That's pretty understandable. People want to go out and map existing utilities that are in the ground. It may be because they're concerned that their maps are inaccurate. It may be because they've never had a map of that particular area. A lot of companies buy other companies that already had facilities in the ground, and maybe they didn't get the maps with that. Mapping of difficult locates. If you're going to send your special technicians out to a job site where you're having difficulty locating, and you're going to spend 30 minutes to an hour or multiple hours trying to get this locate done, mapping that locate is a very good idea, because what it lets you as a company know, and another technician in the future know, when they go out to do this locate, they have an example or an idea of where it was mapped. Mapping of unlocatable utilities. This may not make much sense, but go back to the comment I made before in reference to mapping of unlocatable utilities. If you had taken the time to insert a Jameson rod into a gas line and map it out, you ought to take the time to go ahead and map it so that you can store that data. Updating existing maps, that kind of goes back into before of mapping existing utilities. A lot of as-builts in the past were done off measurements off of curbs or maybe edge of pavement. We all know curbs can change. We all know edge of pavements can change. So updating existing maps with this device helps there too. The last one is one that a lot of contractors are using this for, digital as-builts. A lot of contractors are required to turn in a digital as-built of the work they've installed. A lot of them are also required to prove that that facility is locatable before it's turned over to the facility owner. So that does two things. By locating the utility, you're proving that it's locatable, and by mapping it, you can turn in a digital as-built. So a couple of things that we've added in with the VLOC 3 series that also gives technicians an idea of whether locate is good or not is we've added some warnings in. One of them is a swing alert. So if you're not holding the locator properly or swinging the locator properly, that could cause an incorrect locate or maybe not an accurate locate. It will actually vibrate and give you an icon on the screen to let you know that you are swinging it too much. Overhead alert. This is one that I really like. It's helped out on several locations. This lets me know if the top antenna is getting more signal than the bottom antenna. Signal should always be coming from the ground up. And if your top antenna is seeing more signal than the bottom, then something is wrong. Your signal is somewhere else. It could be over your head on an overhead power line, or in a couple of cases that I've seen, the return signal was coming back on top of a chain link fence, which was causing a mislocate. So anytime the top antenna has more signal than the bottom, the overhead alarm goes off. Overload. If you are in an area with a lot of 60 hertz signal coming from electric, that is just overwhelming your antennas, the overload indicator comes up. Also, if you have too much power or current coming out of your transmitter, the overload will come up. Shallow depth is one that helps a lot of people, because if you are locating a gas service and you're in a backyard and your shallow cable alarm is going off, there's a good chance you've bled over onto the cable TV or telephone, or you probably should know that maybe your gas line is too shallow. So another thing that we've added in the VLOC 3 series that's going to help you in this mapping scenario is a lot of technicians will go to a job site and they're having issues, having trouble locating. Well, you immediately want to rule out, is it the locator? Do I need to have it checked? Is it broken? You can run a self-test in the field. This allows you to know the receiver is working properly. If you know the receiver is working properly, then you know your problem is a job site utility issue and not an equipment issue. Also, this self-test, when you run it, it is stored in the memory with date and time, so that if you needed to, you could go back and check the last time that your technicians did a self-check on the receiver. Marking or mapping marker balls was also a request. Go back to the job site I mentioned before, where they had inserted a Jameson rod and had put the near surface markers in. We do have the ability to mark those EM markers, and it will in our cloud, it would actually show up as the icon you see in the picture on your right-hand side. Now, it doesn't stay that way as you export it into your own database. At this time, appreciate your patience, and I'm here for questions and answers.
Fantastic, Mark. I really learned a lot in this session. A couple questions have actually been asked, so let's go and get to those. First one I've got is, if I record the GPS with this locator, how accurate within feet will this data be able to be found a couple of years from now using cell phone GPS data?
All right, so once again, we have 3 stages basically that the GPS would be in. We have your, what you might consider sub-meter, which is when the icon is red. We're getting SBAS corrections at that point, which is, keep in mind, sub-meter is basically would be 3 feet or less, and that's not consistently, that's on the average. All right, we have the RTK float and the RTK lock scenario. When you map, you will see on our screen the estimated accuracy that you're mapping at. So with an RTK lock, we're generally in the 1-inch area. In the future, being able to walk back to that point would be very accurate if you're using a device that has, once again, high accuracy. If I've mapped a point down to 1 inch with my system, but you want to try and walk back using a phone that has recreational grade, the accuracy of your phone is going to be the issue, not necessarily the point that we had pre-mapped. Now, I mentioned the walk back feature earlier. So if I've mapped something down to 1 inch, I go back out a year from now, I've got my RTK corrections, I've got a RTK lock, I've got 1 inch accuracy. I'm gonna be able to walk back to that point very accurately.
Very good. And it is important to note that that RTK mapping, or that RTK accuracy, is a lot more accurate than the recreational grade that we have on our phones, because anybody that's ever used GPS on their phones, it just is never right.
Yes, that's correct.
At least it never extremely accurate.
Yeah.
Second question I had is, do you need a transmitter to use the mapping feature of the RTK Pro?
So if you're going to map an underground line, yes, you need to energize that underground line to put a signal on it and map it. That's only part of this answer. We also have passive forms of locating. So within the receiver, we have multiple power passive frequencies. We have a radio mode, and we have what's called CP120, or cathodic protection mode. So if you wanted to map using the power passive mode, the CP120 mode for locating your steel cathodically protected gas lines, or use the radio mode, we do allow you to map that way. You're not using a transmitter at that time. You are locating the signal that is naturally on the utility to map it. The third part of that is, as an example, particular customer that I have, they needed to map their utility and give an edge of pavement measurement. So what this contractor does is that we'll locate the utility with an energized signal from the transmitter. On the way back, not using the transmitter at all, they're going to be mapping the edge of pavement. Same way if you were to map a valve, meter, water hydrant, fiber handhole of that scenario, you're technically not using any part of the transmitter. You're using the receiver by itself to GPS map those points that don't have signal on it.
Okay, good. Next question I have is, how much does it cost to use the VVAX Cloud account? And is there a charge at all for this?
So the VVAX Cloud account is free, and it is it's not limited to a certain amount of data, so there's no charge there. Now, the things you will have to pay for, just as a review, you will need a SIM card with a voice and data plan. So you've got to pay for that. All right. There's 2 ways to do that. Some customers just add a SIM card to their current plan. Some customers do a monthly pay for their SIM cards. I've actually had other customers just take a SIM card out of a phone and put it in their receiver while they want to map, and then put it back in their phone when they're done. So but you do have to have some type of a cell service that's paid for outside of EVAX. That's your customer's choice. The other part is the RTK service. You do need to pay for the RTK service if you're in an area that the DOT doesn't give it to customers for free. Just a few quick examples there. State of Missouri is free. State of Arkansas is free. I live in the state of South Carolina. South Carolina DOT does not offer it for free, but it's very inexpensive. It is $600 a year to sign up, and then $500 a year after that. So different states have their different price ranges and so forth. Some are extremely, some are free, some are very inexpensive, some are a little more costly. If you're in a state that doesn't have the DOT service, then you're going to have to seek out a service provider for your RTK services. But no charge for the cloud, the main answer to the question.
Okay, that's great. What are some of the updates or improvements to this unit that VVAX anticipates in the future, and then how would the customer get those updates? I know you talked about that a little bit, but.
Yep. So just as a little bit of history, when we came out with this unit about a year ago, it would only map an underground line, and you could only name it as a gas line, water line, so forth. As we progressed through customer feedback, we changed that to where you could map surface items, and you could also put a more detailed name to that utility, like I said before, steel gas main. That was a software upgrade. The next thing that was a major software upgrade was being able to add was the walk back feature, being able to walk back to a previously mapped point. So going back to that same part of it, being able to walk back to a previously mapped point, a lot of customers have years and years of data in their systems already. They want to use our walk back from a lat long that was mapped with another device. So here fairly soon, there'll be a software upgrade on our receivers that will actually let you manually on the receiver input a lat long that was mapped with any other device. Once again, that'll be available through a software upgrade where you use our free app. So if you went to vvax-metrotech.com, go to our download section, you would see the MyLocator 3 app. It's a free download. Put that on your laptop or desktop. You would connect your receiver up to it and get that update. So being able to walk back to another point is coming up soon. Another update that's going to be coming soon is if there's any GIS people on this call or on this conference, you will, some states map in what's called like South Carolina State Plane or North Carolina State Plane. And that datum system's a little bit different. We convert that on the backside through our cloud now. Some of the data storage software converts that as it comes into the system without us having to do it. But a lot of users out there want to be able to set the device up to map ahead of time that way. So that's another update that's coming. Once again, every bit of that would be through our app. It's free. You just got to make sure you got an internet connection and our app on your device.
Okay, great. And I've got one more. Do you anticipate, and I think this is a good question, do you anticipate these locators taking the place of near surface markers or marker balls because of the use of the walk back feature and the accuracy of the RTK locate?
So in the beginning, I would have never thought this, but we have had customers, once they've mapped with this unit and they use the walk back on this unit, have come to the conclusion that they probably will stop using marker balls and use the walk back. And their thought process behind that is once you put a marker ball in the ground, it is there unless someone excavates in that area, removes it, puts it back in the wrong spot, or doesn't put it back at all. The other scenario that some customers have come up with that they explained to me was if you put a marker ball in the ground and mark a line, and then for some reason that becomes a abandoned utility, the marker balls are still there. If you put another line in close to that, the technician will have to define which marker ball is the one they need to mark. So those are some situations and scenarios that people have come back with of why they probably will not use marker balls once they start using our vault bag.
Yeah, that makes sense. I mean, to me, that's a huge potential benefit, because marker balls can be challenging sometimes.
Yep.
Like you said, they're there until they're
Yep.
until they're not there.
Yep, exactly. And you know, Mike, let me mention one more thing that I failed to mention earlier in the presentation was, and I get asked this question a lot, was there are customers out there that have other brand equipment. Mentioned that before. And the conversion process over our receiver would be fairly simple because we're using a standard screen, nothing really special, right? But we get asked the question lots of times about, can I use my current transmitter? If I have a different manufactured locator and a different manufactured transmitter, I want to use your mapping receiver but continue using my transmitter. Is that a possibility? Yes, VVAX has thought about that. We've got a huge list of frequencies within our receiver that if it's not one that's turned on when you receive it, you can go into the menu, turn those frequencies on, and use other manufacturers' transmitters along with our receiver.
That's a great point, and I think a lot of people don't even realize that at all. So, well, that's, man, Matt, thank you very, very much for sharing with us today. I learned a lot. Before we kind of close out, do you have any final thoughts that you'd like to share before we go?
I would just like to say that, you know, we came out with this in the beginning of COVID. It was very difficult to get this in front of a large group of people. It was a minimal amount of people was able to show it to in the beginning, but the enthusiasm from the customer base has been great. Feedback from customers has been great. That's where some of our new features have come from. I enjoy every time I go out to demo this thing. I appreciate everybody's time today and their patience and your attention span on listening to this, and would love to hear from you.
Well, we appreciate you. Thank you again, Matt, for everything. I hope everyone got some great information out of the session this morning. You know, we want to thank also everyone in attendance today, and I want to remind you that if you registered for this session and attended, you are already entered into the drawing for the door prize that I mentioned earlier. So you'll be contacted once we've drawn the name via whatever information you left in your registration, and we'll get your shipping information so we can send you your prize. And hopefully we were able to get to everyone's questions with our limited time, but if for some reason we missed a question, or if one occurs to you later on, we'd like to make sure that you get the answer that you're looking for. We'd kind of not be very good if you didn't get your answers. So we've created a couple different ways you can get a hold of us. One is a special email address that we created for this conference, and you can see that on your screen. If you'd like to send us an email with your questions, we'll get an answer back to you just as soon as possible. You can also contact us via our main phone number, and we'll try to get you routed to the best resource to get an answer for you. And then you can always reach out to your EGW representative, because our guys are pretty knowledgeable on this stuff, and they're great sources of information as well. Thank you again, everyone, for joining us this morning. We enjoyed it. We look forward to seeing you guys again in the next session, which is a general session, the perfect storm, the 2021 polyethylene shortage and how we got here, which begins at 1 o'clock Central. We'll see you guys at 1. Don't forget to register for that session if you haven't done so already. It's going to be very, very informative. Otherwise, thanks, everybody. Appreciate it.